Hello boys and girls, how's it going? Hopefully you're doing well. Today we are going to learn how to convert fractions into decimals. Now this is a completely new topic. It's something that we have not learned before. So it's important that we understand just what we learned in Maximo with teacher Joel and with teacher Julia, and we apply that knowledge. Last time we were working on finding equivalent ratios and fractions, okay? We are already looking at those proportions. So we already kind of understand what a proportion is. It's basically just a part compared to a whole, okay? So if we take a look at these problems, for example, we could take a look at 3 divided by 2. What 3 divided by 2 is we're basically just seeing how many 3's enter a group of halves. All right, so since we have the understanding of what halves are, for example, this is 1/2, we're going to see how many of those enter groups of 2, okay, in a half, all right? So I know that 2 can enter 3 at least one time, but what we're going to do is we're going to change this to an improper fraction, okay? That's what the directions say. So 3 divided by 2 is the same thing as 3 over 2. Let's go to the next problem. 5 divided by 3 is the exact same thing as 5 over 3. In other words, 5/3. Okay, so the first one we have 3 halves. It's just 3 divided by 2. And the second problem we have 5/3. It's just 5 divided by 3. Pause the video and try to see if you can do the next one on your own. All right, so that last problem should have been 7 over 4. In other words, 7/4. All right, what we're going to do is go to the next page, page 51. On page 51, we're going to do a little bit different problem. We're going to write the division problem as a improper fraction, okay? As an improper fraction, we can take 8 divided by 3. Well, I know that 2 times 3 equals 6, which comes very close to 8, right? It doesn't exactly come to 8, but it does come close. So 6 comes really close to 8. And what I need to do is, I know that 3 times 2 is going to come into my bigger number, right? So 2 is going to be my whole number. But what's left over? Well, we have 2 left over. If we take 6 plus 2, we're going to come up with our regular number right here, okay? All right, so 2 is going to be our numerator, and our denominator is going to stay the same. That 3 is going to stay the same. So we have 2 and 2/3 as our final answer for our improper fraction. Okay, let's do the next one. How many times can 3 go into or enter 10? Well, I know that 3 times 3 equals 9. That comes pretty close to 10. So my whole number is going to be 3. But how many more numbers do we need to know before we enter our larger number, right? Our dividend, right? How many more numbers? Well, 9 plus that extra 1 is going to come close to our dividend, right? 10. So 1 is going to be my numerator. Put my little line right there. And what would be our denominator? Well, the same number that we had before. That 3 is our same number. So 3 and 1/3 is our final answer. Okay, let's try the next problem. How many times can 5 enter or go into 12? Well, if we take a look at our trusty multiplication table down here, I know that 5 can enter 12 just 2 times. If we went to 3, we would actually go over. Wouldn't be 15, right? So just 2 times. 2 times 5 equals 10. And I know that 12 minus 10 is going to give me 2. That's going to be my remainder. Okay, so 2 is also going to be my numerator. What's our denominator? Well, it's our number that we're dividing by, right? divisor is 5. It's the same as our denominator. So 2 and 2/5 is our final answer. Go ahead and pause the video and do the next 3 on your own. All right, so these problems, boys and girls, 4 can go into 11. Let's count by 4s. 4, 8, 12. Oh, just 2 times. 2 times 4 is 8. Now 11 minus 8 is going to give us 2. So that's going to be our numerator. 2 and 2/4. Sorry, that should be 2 and 3/4 because 11 minus 8 is 3, right? Oops, I just erased everything. Now let's try that again. 2 and 3/4. Let's check that to make sure that it's actually the correct answer. 4 goes into 11, 4, 8, 2 times, and 11 minus 8 equals 3. So 3 is our numerator, and 4 is going to be our denominator. All right, how many times does 5 go into 23? Well, 5 times 4 equals 20. So 4 is going to be my whole number, and 23 minus 20 equals 3. So that's going to be my numerator, and my denominator stays the same. 5 is my denominator. How many times does 3 go into 20? Well, if you count by 3s, 3, 6, 9, 12, 15, 18. So 6 times. 6 times 3 is 18, and 20 minus 18 equals 2. So 2 is going to be my numerator, and my denominator always stays the same, which is 3. Boys and girls, check your answers to make sure that they are correct. And we're going to go on to the next part on page 51. All right, so let's take a look at the next part of page 51. This time what we're going to do is write an improper fraction or a whole number. Okay, so we have, again, 2 can go into 8. How many times? 4. How many times can 5 go into 11? Well, let's count by 5s. 5, 10, oh, just 2 times. But what is left over? 11 minus 10 equals 1. So 2 and 1. What's our denominator? 5th. 2 and 1/5. All right, let's try the next one. How many times does 8 go into 17? Well, 2 times 8 equals 16. So 2 is going to be my whole number. And 17 minus 16 gives me 1. That's going to be my numerator over my denominator, which is 8. 2 and 1/8 is my final answer. Let's take a look at this last problem. How many times does 3 go into 27? Well, in this case, you already know that it's not going to be an improper fraction. It's going to be a whole number because 3 times 9 equals 27. So 9 is your final answer. Check these problems to make sure that you have them correct. Let's go on to page 52. On page 52, we're going to change these improper fractions to decimals. So let's try it. I know that 5 can enter 6 at least one time. So I'm going to do some long division to try to figure that out. First, I'm going to put my whole number right here. Our answer is going to include the whole number 1, but we also have a little bit more of our answer to complete after we do the calculation. If we have 6 divided by 5, I know that 5 can enter 6 just one time. 6 minus 5 equals 1. Now, I still have a remainder, but my directions say that I need to express my answer as a decimal, which means that I'm going to include my place value with a decimal point right there, and I'm going to add an extra 0. Okay? It kind of looks like we are dividing 60 by 5, but in reality, we need to bring our decimal point into our answer so that we can continue our problem. Let's bring our 0 down, and now let's ask how many times does 5 go into what looks like 10? There's actually a decimal point right there. 5 times 2 equals 10. All right? So our answer, boys and girls, is 1.2. Okay? If I did that on the calculator, it would come up with the same exact answer. Let's go to the next problem. How many times does 8 go into 10? Well, I know that 8 times 1 equals 8. So my answer is going to include a 1 and then a little bit more. It's going to be a decimal. So I'm just going to put my decimal point right there. Let's do the long multiplication to try to figure out the answer. 8 can go into 10 one time. 10 minus 8 equals 2. Now, just like I did before, I'm going to add my decimal point because 10.0 is the same thing as 10. It's the exact same number. All right, there's my decimal point. You can see it a different color. And I'm going to add my 0 right away. I'm going to actually add 2 zeros right away and extend my problem. Let's bring that decimal point up into our answer and continue our problem by bringing our 0 down. How many times does 8 go into what looks like 20? Technically, it's 2.1. 2 times 8 is 16. So 2 times 8 is 16. I don't have a whole lot of space right here, but 20 minus 16 equals 4. Okay, we could continue this problem. Our answer is going to be approximately 1.2. Okay, technically, if I continued it, I would bring my 0 down, and then I know that 5 times 8 equals 40. I could just take 40 minus 40, and my answer would technically be 1.25, or 1/2500. We're going to continue with letters C and D during the next class, but this is just a taste of how we can change improper fractions to decimals, and then also how we can change improper fractions to whole numbers, and try to figure out division as improper fractions, as well as just kind of understanding the relationship between division and improper fractions. I hope that you all have a great weekend, and we will talk to you next week.